Hello children, in the previous lecture you learnt about refraction of light, angle of incidence, angle of refraction, refractive index, optical density in terms of speed of light in different media and refractive indices. Today I will start with relative refractive index because in previous lecture you learnt about absolute refractive index, and then I will discuss laws of refraction. So let us start with relative refractive index. Relative refractive index. You know absolute refractive index is mu is equal to speed of light in vacuum by speed of light in the medium, C by V. Here C is the speed of light in vacuum and V is the speed of light in medium. This V can also be represented by Cm, means V can also be represented by Cm, means the speed of light in the medium. And in some books you can see C naught in place of only C to represent velocity of light, speed of light in vacuum. But here I am using C for speed of light in vacuum and V for speed of light in the medium. So this is the absolute refractive index. I discussed in the previous lecture the C is always greater than V. So this mu is always greater than 1, means absolute refractive index of any medium is greater than 1. It is 1, which is minimum absolute refractive index for vacuum. And for convenience we take mu is equal to 1 in place of air also. Although it is somehow greater than this, it is 1.0003, but we use mu is equal to 1 for air also. Now what is relative refractive index? You know the meaning of relative. Relative means comparison, comparative, means refractive index of a medium in comparison to the standard refractive index. So a standard refractive index is refractive index of vacuum. And if you have refractive indices of two different media, you can compare their refractive indices. So refractive index of one medium with respect to the other medium is called relative refractive index. Suppose mu1 and mu2 are refractive indices of two media. Then 1 mu2 is equal to mu2 by mu1 is called relative refractive index, relative refractive index of the medium 2 with respect to the medium 1. So is it clear? Relative refractive index means refractive index of a medium with respect to the refractive index of other medium. If it will be written 2 mu1, then it will become mu1 by mu2, means the relative refractive index of the medium to be determined is taken as the ratio of its absolute refractive index to the absolute refractive index of the other medium. Is it clear? Now see, this mu2 is equal to C by V2 because this is C by V, and mu1 is equal to C by V1. So you can write V1 by C. Here mu1 is equal to C by V1 and mu 2 is equal to C by V2. So this will become V1 by V2. You see, relative refractive index is ratio of mu 2 by mu 1 and V1 by V2. You see, absolute refractive index of medium 2 is numerator, and here speed of light in medium 1 is numerator. Means refractive index is inversely proportional to the speed of light in that particular medium. This is the definition of relative refractive index. After knowing about relative refractive index, we can express this V1 and V2 in terms of wavelength of light. You know V is equal to nu lambda. You already learnt V is equal to nu lambda in class 9. So this V1 can be written as nu lambda 1 and V2 can be written as nu lambda 2. As the frequency never change with change in medium, so nu will remain same, but wavelength changes to cause a change in the velocity. So wavelength has been changed. It is equal to lambda 1 by lambda 2. Lambda 1 by lambda 2. So in general you can write 1 mu 2 is equal to mu 2 by mu 1 is equal to V1 by V2 is equal to lambda 1 by lambda 2. Is it clear? This is the relative refractive index of second medium with respect to the first medium. Now I will discuss laws of refraction. Laws of refraction. First law. First law. The incident ray, the refracted ray and the normal all lie in the same plane. You just understand, this is the plane, this is the incident ray, this is the normal at the point of incidence, and this is the refracted ray. AO incident ray, OA dash refracted ray. This is the angle of incidence I, angle AON, and angle N dash OA dash is angle of refraction. So you see incident ray, refracted ray and normal at the point of incidence all lie in the same plane. Just you understand the meaning of this same plane. Suppose this is the plane, here is the medium 1 and below this plane medium 2 exists, and this plane is the interface separating the two media. This is not the independent plane, this is the plane separating the two media, interface separating the two media. So you see incident ray, refracted ray and normal all lie in which plane? In this plane, not in this plane. Is it clear? There is a confusion among the children that this is the plane in which they lie. No, this is wrong concept. This is the plane in which they lie. Suppose this is the plane separating the two media, then this will be the plane in which incident ray, refracted ray and normal will lie. Is it clear? Have you understand the concept? Okay, so this is the normal, this is the incident ray, this is the refracted ray. I think you understood the fact. Second law is related to the angle of incidence, angle of refraction and refractive index. So second law was given by Snell, hence it is also called Snell's law. Snell's law. Second law is also called Snell's law because it was proposed by Snell. This states that the ratio of sine of the angle of incidence, you see I is the angle of incidence, So ratio of sine of angle of incidence to the sine of angle of refraction, sine of angle of refraction is always a constant. And what is that constant? That constant is 1 mu 2. This is the constant. Means this 1 mu 2 is constant. For the given pair of media, this must be added there. Means the ratio of sine of angle of incidence to sine of angle of refraction is always a constant for a given pair of media, and that constant is relative refractive index of second medium with respect to the first medium, that is 1 mu 2. You can explain it 1 mu 2 as mu 2 by mu 1. This is also equal to V1 by V2. Means sin I by sin R is equal to 1 mu 2. This is Snell's law, and this can be related to speed of light also. This can be related to refractive, absolute refractive indices of the two media also. So I think you understood this first law and second law. On the basis of this, you can understand the situation when a ray of light is incident along the normal. It was discussed in the previous class that when a ray of light is incident along the normal, then what will happen? You see, when I becomes 0, when this I becomes 0, it means AO is along NO. And if I becomes 0, sin I becomes sin 0 by sin R. It is equal to 1 mu 2. If you want to find sin R, you see sin R is equal to sin 0 by 1 mu 2. Sin 0 is 0. This gives you sin R is equal to 0. And sin R will be 0 only if R is equal to 0. And what is the condition for refraction? That R should not be equal to I. And here I and R are equal, both are 0. Means there is no deviation in the ray of light during its passes from one medium to the other medium. Hence this case of transmission of light is not taken as a refraction of light. Another situation in which again the refraction of light will not be taken into care, if the two media have same refractive indices, means they are having same optical density, means if there is no change in the optical density of the medium, then there will be no refraction. Is it clear? So today you learnt a relative refractive index, you learnt laws of refraction, you learnt the condition in which ray of light changes its media, but refraction is not taken into care. So with this, I am concluding the lecture now, and in the next class you will be learning about refraction at spherical surface, refraction at plane surface. That is, the idea of lens will be introduced to you. Thank you.